All right, so today we're going to talk about sound, specifically music. So, what exactly is music? Music is created using specific pitches and sound quality and using them in a regular pattern, whereas noise has no pattern and it has no definite pitch. An example of a noise is something called white noise. Now, white noise is different in the sense that it has all the frequencies of the noise are at the exact same amplitude, or remember, amplitude is the same amount of energy. Example of something of white noise would be the old TV screens where you have like the white, black and white fuzz, and they that type sound. That's an example of white noise. Acoustics. Acoustics is the study of the science of sound. We're going to be using acoustics in studying the sound quality, for example. Now, this describes the differences between sounds of the same pitch and loudness. So we take a look in the example here. We have a flute and a piano. They play the same pitch and the same loudness. They're not going to sound the same. This is because they have different sound quality. Fundamental frequency. Now, the fundamental frequency is the lowest frequency present. Now, an overtone is a vibration whose frequency is a multiple of that fundamental frequency. So here we have in music, we have, let's say here we have the lowest frequency that you're hearing at that time. That's the fundamental frequency. If there are frequencies higher than that, F at the next higher level, right? These are known as overtones. It's the same frequency who is at multiples of that fundamental frequency. Now, in the stringed instruments. Now, stringed instruments are, of course, use a string and that's vibrating to make the sound, and it vibrates at its natural frequency. This vibrating produces a wave that's a standing sound wave. Remember from before, a standing sound wave is a wave where the crest and the trough are always going to be found in the exact same place. You look at the strings of a stringed instrument, the shorter they are, the faster they're going to vibrate. The faster they vibrate, that means they're going to have a higher frequency. A higher frequency means that it has a higher pitch. Now, in a stringed instrument, a lot of times you'll have something called a resonator. Now, this is a hollow chamber filled with air that amplifies sound when the air inside it starts to vibrate. Like an acoustic guitar, for example. Now, for wind instruments, of course, use air as their main force of making sound. Now, the speed of sound is constant for wind instruments. But what happens is that one of the things that changes the pitch is the length of the tube. The longer the tube, the lower the pitch. Some other things that determine the tone quality of an instrument, it depends upon one, like the mouth size, or the mouthpiece size, sorry. For example, like a French horn has a very tight mouthpiece, whereas a tuba has a much bigger mouthpiece. The size of the tube also makes a difference. All right, comparing the tube of a piccolo, which is very short, has a very high pitch, versus that of, once again, like a trombone, which is a lot lower pitch, or a tuba. And then, of course, the material that it's made up of, whether it be made up of wood or brass or something like that, also has an effect on the tone quality of an instrument. And we have something called beats. Beats is simply the variation in loudness. And I want to play this for you guys. It explains it really well.
Tab, and in that tab, I'm going to briefly change what note I'm playing. So that's 440 hertz. That's also 440 hertz, but listen what happens when I change one of them. Those are beats. Now they're gone. And now as I go above it, you can hear the beats again. And as I bring them back to the same value, then it goes away. Now, when would this be useful? Well, let's say you're tuning your guitar. What you can do is tune one of the strings. So make sure you tune that to a tuner or a piano or something like that. Once you have that, then you can play another string. You have to move up on the fret, but play another string. And if it's close, you'll hear the beats. And if it's exactly the same, you can adjust the one. then the beats will go away. And then you can move on to the next string and the next string and the next string.
Now, so that's pretty much the stuff we're going to have for music. If you would like more information or a little bit more deeper understanding, there are links in the slide. Check the description below and click on that link to access those slide notes.